So here we have another one. This is going to be exercise 3-1. And for this one, we have a resistor coming through, over, up, positive, negative. We have a resistor over, we have a resistor over. We have something coming down, a resistor over. We've got 4, we've got 10, we've got 1, we've got 6, and we've got a 24-volt source. All right, so first thing we're going to do, follow the same procedure as the last one we did. 1, ref nodes, ref node. We made our reference node right there, done. 2, let's grab label node voltages. All right, so which ones do we have as node voltages here? We've got this one. Do you have any other node voltages? Not really, no. That's going to be our only node voltage. So the reason why I'm not doing one here is because the current coming through here is going to be the same. So if I just add these kind of up together, we're kind of have one resistor of 10, and that's the current coming through. So if I have to calculate the voltage drop later, I can still calculate it with this one current because the current's going to be the same because there's no current divider in here. There is a voltage divider, but we can use the same current to be able to calculate through things a little easier a little bit. So anyway, label node voltage. So we've done that. We're going to call this V1, okay? And then 3, we're going to draw currents. Draw currents. All right, so remember, currents come out of the node, out of the node, out of the node. And what do we want to call them? I1, I2. It doesn't really matter at all. Okay. And that's it for that one. We've drawn our currents. 4, solve easy nodes. Are there any easy nodes here? No, there's not. We only have one kind of complex one because it has 3 coming out of it. So we can't even do that one. 5. What do we got for 5? KCL at other nodes. KCL at other nodes. All right, so we'll start our KCL up. KCL right here. We've got KCL, and we're going to do this at node V1. So that's this node right here. All right. KCL. I1 plus I2 equals 0. Okay. So our first one, I1, we're going to go here. We're going to do I1 equals V1 minus 0. So V1 minus 0, I'm not even going to write it, over 10 because it's a total resistance coming through there. V1 minus V0. Fine, I wrote it. This is V0 down here. V0 equals 0. There, nice and easy. Now we know it. So that's our first step. Plus, our second step is we got V1 right here minus V0 over 1. V1 minus V0 over 1 ohm resistor. And we've got our last one. Ooh, we have something special here. We have a source and a resistor. That's cool. All right, we have something fun. So we're going to start with our V1 here. We're going to subtract exactly what we need here, which is minus our source, 24, because we're going through the source. And then what else are we going to subtract? We're going to subtract the V0. And again, V0 equals nothing, so we can get rid of it later. And then in this path, there's also a 10 ohm resistor equals 0. So first thing we're going to do, the V0s are equal to 0. I'm just going to cross them out so we don't complicate anything. That makes it a little easier. If we take each one of these then and we multiply them by 10, we're going to get V1 plus 10 V1 plus V1 minus 24 is going to be equal to 24, right? Let me just check. Have I messed anything up there? No, that looks good. So we're going to get 12 V1 equals 24. V1 equals 2. Boom. Got it. And so if we're trying to do V equals IR, we can do V equals IR. We can do 2 equals I times 1 to be able to determine the current coming through here of I. I equals 2. That's this current coming down. That's our normal I. All together, nice and easy on that one. Let's try again for another one.